Greetings. This is part 1 of a calculator tutorial designed to show basic graphing calculator skills for parametric equations. Parametric equations are a topic which lends itself to experimentation with a graphing calculator, as a calculator can help you better understand what parametric equations are and how they behave. So let's get started. You first need to switch from function mode to parametric mode, and the way that you're going to do that is you're going to go into your mode and you're going to scroll down to the 4th line. Right now we're in function mode, but if we arrow over and we press enter, we'll switch the graphing calculator from function mode into parametric mode. Additionally, while you're in this particular window, make sure that you're in radian instead of degree mode. When you do any trigonometric equations parametrically, you're going to want them to be graphed in radians. And also make sure that you're in connected mode and not dot mode. Okay, so we switch from function mode into parametric mode, and let me just take you around a few places in your graphing calculator so that you can see what the major differences are when we're in parametric mode versus when we're in function mode. First place we're going to go is we're going to go into our equations, and in our y equal menu you'll notice that your 10 y equal functions have been replaced by 6 pairs of parametric equations. Parametric equations come in pairs, as when you're graphing something parametrically, you are graphing your x coordinate as a function of time as well as your y coordinate as a function of time. So any motion you're trying to simulate with parametric equations have to have an equation for your x coordinate and your y coordinates, and again both of those as a function of time. A second major change is if you access your table in parametric mode, you'll see that rather than an x coordinate up here, you'll have time values, and this is going to be your initial default setting for your table. And when you graph a set of parametric equations, you'll see values for your x coordinate and your y coordinate appear in these columns. And third, and a really major change, is inside your window, in addition to your xmin, xmax, xscale, ymin, ymax, and yscale inputs, you'll notice that there are 3 additional inputs: tmin, tmax, and tstep. Xmin, xmax, xscale, ymin, ymax, and yscale, they set your viewing window in parametric mode just as they do in function mode. Your tmin, your tmax, and your tstep, those 3 additional inputs correspond to your equations in the following way. Your tmin and your tmax are going to be your minimum and your maximum time interval that you care to simulate motion along, and your tstep value are going to be the number of time increments you're going to ask your calculator to plot given your particular time interval that you're concerned with. Alright, so let's move on to a specific example that we can graph. The example that I've chosen is in your textbook on page 526, and in that particular example we want to move along the line segment that starts at coordinates -2, 3 and ends at coordinates 3, 6. You will soon learn how to figure out the parametric equations that will actually create the line on which those 2 points lie. But for now, we will tell you that those 2 equations that you will need to graph in order to create that line are your x coordinate as a function of time should be the equation -2 plus 5t. So we'll go ahead and we'll enter that as our x coordinate as a function of time. And we have to plot our y coordinate as a function of time in order to again create that line of which those 2 points lie on. We have to graph the equation 3 plus 3t. While we're in this particular menu, what we'll want to do is we'll want to change the nature of how the segment is plotted, and we actually have a number of options in which we can do that, some more visual than others. This option will allow us to see dotted lines. That option will be a much heavier bold line that will be created. This option will be a circle with a trailing segment behind it. That's just a plain circle. And that's more widely spaced dots. In my opinion, the most visual plot to see is a circle with the trailing line segment. Okay, so we'll select that as the way our plot will be displayed. So we'll quit out of this and we'll go to our home screen. And the first place that we should go is if we were to access our table. Now our table is different. In addition to those time values you saw as a default, we can now see what our x-coordinate as a function of time and our y-coordinate as a function of time will be for very specific time values. And if we scroll down in our table, we'll note that when time is 0, our x-coordinate is -2 and our y-coordinate is 3. And when time is 1, our x-coordinate is 3 and our y-coordinate is 6. Now keep in mind that we wanted to plot motion along the line segment that began at -2, 3, and 3, 6. So we can see that in order to get that segment, we need to set a minimum time of 0 and a maximum time of 1. That will accomplish what we need or what we want to accomplish. So now when we go to window, we're going to set our minimum time at 0 and our maximum time at 1. We're going to change our step value to 1. We need to see from -2 to +3 in the x direction. So I'm going to go from -5 to 5 with my x-min and my x-max just to be a little bit wider in the x direction than what we actually want to see. And remember, our y-coordinates are 3 for our first point and 6 for our second point. So instead of -10, I'll just change that to 0 because we don't need to see that much of the y value. And a y maximum value of 10 is fine. Okay. So again, we've set our window. We have a nice viewing window. We know that we need a minimum time of 0 and a maximum time of 1. That'll start us at that point -2, 3, and it'll end us at that point 3, 6. We have a step value of 1. So we're ready. We hit graph, and relatively instantaneously, the line segment is created. And to verify that we're seeing the actual line segment from -2, 3 to 3, 6, you want to hit the trace button. The trace starts us here at time 0, we're at -2, 3. And if we try to trace along this segment by hitting the right arrow, it immediately jumps us to 3, 6, where time is 1. The reason that it jumps us immediately from the beginning to the end is that we've set a step value of 1. So what you're telling the calculator to do is to start you at 0 seconds, end at 1 second, and just do it in a 1 second increment. So it's going to jump you from the beginning of the line segment until the end. If you want to go over that 1 second interval in more frequent steps, then what you need to do is you need to set a smaller step size. Okay, let's set a step size of 0.5, again, so that you can get a sense of what your t-step is doing. When we hit graph, relatively instantaneously the segment is created. And this time when we hit trace, notice that it starts us at time 0, where we're at -2, 3. If we try to trace along the segment, it'll let us trace to a 0.5 increment, and we can see what our x and y values are when we're at time 0.5, and again it'll trace us to the end where we're at time 1 second, we're at the point 3, 6. And again, because you asked for a step size of 0.5, It's going to give you the beginning value. It's going to give you that halfway value through it, and it's going to give you that end value. So if we want to see more steps, we set that to a smaller size. Let's do 0.1 this time. Hit graph, and you can see a graph ever so more slowly because you're actually asking the computer to, your calculator to cycle through a lot more time values. Notice now when you trace, you can trace through in 0.1 increments, which is your step size. And then finally, just to illustrate what's going on with your step size, we set our step size at 0.01, and we hit graph. A couple of things are going to happen. One, your graph is going to move a lot more slowly, so you'll actually be able to see the line segment being created. And additionally, you'll be tracing through in 1/100th of a second increments throughout your time interval. Okay, so the step size is something that you're going to want to set and do by experimentation. Your basic rule of thumb is the smaller your step size, the more accurate your graph will be, but the slower it will graph. So that's always something that you're going to want to experiment with and decide, again, based on how much motion you want to see, how wide your interval is in terms of time values, and really how quickly and how accurately you want the graph to be created. That's all for now. Hopefully this tutorial has given you enough information to get you started. There will be a part 2 of this where we will try to simulate motion around a circle rather than along a straight line. Thank you and enjoy.